Hello and welcome back to Triplicate, home of interesting electronics. Last time we got our Arduino board powered up and we compiled some code and uploaded it to the board and got an LED blinking. So now I guess we should try and do something interesting with it. Now these videos aren't intended just to be a how-to for projects. The idea is to show the process of working through the project, discovering the problems, solving the problems. So that's why I'm starting out from the point of view that I've never worked with an Arduino before. So we're sort of learning together. And I hope in the process to sort of pass on a bit of my experience of doing that, of just having to solve problems without anybody to tell you what to do and give you a video tutorial and whatever. Okay, so what project? Well, when I bought the Arduino, I also impulse bought a board that plugs in the top, that way round I believe, which has a display, a buzzer, 3 buttons and 4 LEDs. Oh, and a little pot. And I thought we'd build a project around that. Just so we could concentrate on getting experience with the Arduino without having to worry about designing and building any hardware. And since we've got some buttons, a 4-digit display and a buzzer, I thought we'd have a go at a little alarm clock. Now again, I don't imagine this is ever going to wake anybody up in the morning, seriously. It's just here for something to build, something to design. Now I believe you can get a library to drive this. However, I thought it would be more interesting and we'd learn more about programming the Arduino if we didn't use that and we worked it out ourselves. So, without further ado, let us plug this onto here, making sure we get it the right way round, and get started. The first thing to do is set up a project. So I have here the very basic blink example and I'm going to save that as our project and use that as a starting point. So without further ado, save as alarm clock. Right, so with a project like this, the first thing I do is get the I/O working. The reason being, we need to see what our software is doing. And unlike a computer where you can conveniently print things onto the screen, the only way we know of what's going on in the code is being able to output things to the I/O. And I thought we'd start with the LEDs. Okay, so to have any idea where anything is on this board, we need a schematic. If we Google Arduino multifunction board schematic and look in the images selection, there are several schematics available and we can just download one of those and look at it. Okay, having got our schematic, I think we'll start with having a look at driving the LEDs. So here is the bit of the schematic that deals with the LEDs, and it tells us that they are driven by pins 10, 11, 12 and 13. The Arduino describes its I/O pins, its straight port I/O pins, as just pins. And we also note that putting the pin low turns the LED on. The reverse logic. Okay, firstly, we'll look at the way the Arduino projects are set up. Conventionally in C, you have a main function, and at the start of that, you call some kind of a setup routine, which sets up all the ports and so forth, and then you have a while loop, which contains your big loop with all your code in. Arduino have, I guess, gone one step further than that, and they give you a setup function and a loop function. The setup function is called once when the code starts up, and the loop function is repeatedly called over and over again thereafter. Okay, in the setup function for the blink program, we have a pin mode call to LED built in and output. I guess we should look at what that function's doing. So if we go to Arduino home, and I'm guessing we want resources, reference, and we're in functions. Good guess, eh? And we look at the pin mode function. It seems Arduino has quite a lot of built-in functions for doing these things. Normally you either have to write your own or call a library. So the syntax is simply pin mode, pin and mode. And the mode is input and output. And the pin gives the pin number. So LED built in is a define, which I think is 13. I think that's the number of the LED. So we are going to set pins 10, 11, 12 and 13 to outputs. Okay, I've decided to spare you having to watch me type. So here we are. I've set those 4 pins to outputs. I've also deleted the comments at the top to do with the blink program. Okay, so what I thought I'd do just for testing is get the LEDs to count. So what I've done is created a counter variable, which is a static, so the counter number's remembered between calls to the loop function. Now it's a uint8t, that's an unsigned integer of 8 bits long, which is defined up here. C is particularly bad at defining types, so it's good practice to define these types so that you know specifically what the variable is. Okay, at the end here I increment the counter so it counts up every time the loop function is called. Then I delay 1000 so it counts up every second. Right, unfortunately at the minute it doesn't do anything, so I guess that's the next step, is to put the code in which actually turns the LEDs on and off according to the value of the counter. Okay, so here it is. The least significant bit of the counter turns the LED on pin 10 on. The next bit the LED on pin 11 on, the next bit the LED on pin 12 on, and the next bit the LED on pin 13 on. This just makes the LEDs count in binary. So let's see what it does. Firstly, we need to reconnect the Uno. And the editor has seen the Uno arrive. Good. And let's compile it and run it, hopefully. Okay, there we go. So just zoom in on that and you can see the LEDs counting up nicely. Success! Okay, moving on. Shall we see if we can get the switches to work? Okay, so what I decided to do with the switches was simply vary the speed of the counter. So now if we look down here, the delay delays by a value of delay val. Get rid of that. This delay val is what I've called a uint32t, which is an unsigned long, an unsigned 32-bit number. Again, a static variable, so it's saved. Okay, so now looking at the switches are actually connected to three analog inputs, A1, A2 and A3. However, looking at the pin mode function, it says in the notes at the bottom, the analog input pins can be used as digital pins referred to as A0, A1, etc. Which is useful. So we go back to here and we've set up the pin modes for those three as inputs. And if we look here, there's a digital read function which reads the pins. So if we say digital read A1, and if that value is low, then that switch is pressed. So we set the delay value to 500. Similarly, the switch on A2 sets the delay val to 1000, and the switch on A3 sets the delay val to 2000. Slow, medium and fast. Okay, let's see if this code will compile and run. Okay, it compiles and it runs. So if I press this button, it counts quickly. If I press this button, counts slowly. And if I press the middle button, counts at its normal speed. Fast. Slow. Medium. Good. Okay, so last night we got the LEDs working and the buttons working, which just leaves the buzzer and the pot. Now I'm not proposing to get the potentiometer working because we don't need it for our alarm clock application. So, to the buzzer. Now, looking through Arduino's built-in functions, under Advanced I/O we find one called tone, and this generates a square wave of the specified frequency on a specified pin, and we also have an option of a duration. So, providing the pin is capable of PWM, that is our function. Okay, looking at the circuit diagram, we see that the buzzer is powered by a transistor taken off pin 3, I/O pin 3. So, if we go back into our code, we turn pin 3 into an output, and because if pin 3 is low, then a DC current will pass through the buzzer. We turn it off when the buzzer's not in use. So then we add to our code, every time we press a button it will turn the buzzer on for 400 milliseconds, make a short peep, and one button is 400 Hz, the second button is 500 Hz, and the third button is 600 Hz. So we should hear 3 different tones, and then after the delay we set pin 3 high to make sure the transistor's turned off. Okay, shall we try that? Okay, that's done. So if we press this button, we get something. And we get something else. Well, not quite what we expected. A short beep. But I guess we can call it a success. We've got some noise out of it. Okay, so we've got the LEDs working, we've got the switches working, and we've got the buzzer sort of working. I'm sure we can look into that and sort that out. However, what we haven't done is got the display working. Well, I have looked into that a bit, and it is a bit more complicated. So what I've decided to do is save that for the next video and make a whole video concentrating on getting the display working. So for this video, that is about it. Just leaves me to thank you for watching. Subscribe please, any comments please leave them, and I'll catch you next time. Bye! Who's a good girl? Hey, good girl. Haven't barked for the whole video. Well done. Come on, give us a smile.